This video is referring to number 18, the very last problem from your review packet that you were given today in class. So if you look at number 18, it says a force of 470 pounds is acting on an object at an angle of 38 degrees from the horizontal. That is in the positive direction. So if I sketch my coordinate plane, I have 38 degrees. That's right there, 470 pounds. It's a fairly large magnitude. So that represents 470 pounds. And this angle in here was 38 degrees. And we have a second force of 379 pounds. It's acting at an angle of -9 degrees from the horizontal. -9 degrees, that is just below the horizontal. And again, it's a pretty large vector. It's 379 pounds. And this is -9 degrees. Okay. So we're asked to find the resultant. Now I'm going to draw a little sketch. I'm going to finish my parallelogram to the best of my ability. That was not very good. Let me try that again. Or I can sketch this way. Remember, these are supposed to be parallel and these are supposed to be parallel, but the resultant is what I get when I add these two vectors together. Which, if I draw this resultant, this point right here is the terminal point of my resultant. So this is what I'm trying to find. This magnitude, this resultant force, and the angle of the resultant force with respect to the force of 379 pounds. Be careful, that's going to come into play. That's talking about this angle, from the red dotted line, the resultant, all the way down to this force, that's 379. So if I'm thinking ahead, I not only have to calculate the angle between the x-axis and my red dotted line, I then have to add 9 degrees to that to get that entire angle. Okay, so that's just setting up this problem. We've got to find the magnitude of this red line, and we also have to find this angle in here. In order to do this, I'm going to have to use the 4 steps to solve this problem because I don't have any right angles set up in here. So I have to find the components of my blue vector. I have to find the components of my green vector. To add those components together, then I can calculate my magnitude and the direction. So let's find the components of the blue vector using the formulas. Hopefully you've got these down by now. X is the magnitude, 470, times the cosine of my direction angle, which was 38 degrees from the horizontal, so I can just write 38 degrees. Y is the magnitude times the sine of my direction angle, which is 38 degrees. In component form, I've already calculated these. That is going to equal 370.365 and 289.36. Again, they're in the first quadrant. They're relatively large numbers. It's a practical vector, x and y component vector for this blue vector drawn here. Now let's do the same thing but with our other vector. X is going to be equal to the magnitude of 379 times the cosine of my direction angle. You have options here. You could put positive 351. I'm just going to put -9. -9 degrees from standard position is just down 9 degrees. You could have also gone all the way around, 351 degrees. You will get the same answer. And then y equals 379 sine of -9 degrees. And I can write this in component form once I calculate to equal 374.334 and -59.2887. Now, if you notice, I'm leaving a lot of decimals. I'm not finished with this problem yet. So I should hold off on rounding until the end. Okay. This was step 1 and step 2. Find the components of your original vectors. Step 3, add those components together. I add my x's, I add my y's together. One thing I wanted to touch on, this is a negative y value. We are in the 4th quadrant. It should be negative. So step 3, add these vectors together, and I get 744.699 and 230.072. This is my resultant vector in component form. This is my resultant in component form. I'm going to take this result and I'm going to make a new sketch. If I have a horizontal of 744.699, that's going to be about here, and a vertical of 230, let's say about here, my vector is going to be in this direction. So this was 744.699, and then 230 vertical. Both are positive. We are in the 1st quadrant. If we go back and look at our original sketch of that resultant, now we have to solve for the magnitude and the direction. I'm trying to find my magnitude of this red vector and this theta angle right there. So magnitude, Pythagorean theorem. This is going to be the square root of 744.699 squared plus 230.072 squared, which is equal to, find my work, 779.429 pounds. Don't forget your units. This is a word problem. The resultant force is 779.429 pounds with a direction. So now we find out what theta is. We use inverse tangent of the vertical component over the horizontal component. That will give me a degree of 17.1685 degrees. That is not my final answer. Remember, the problem, if you go back up here, sorry, I'll come back down in just a second. The problem said, with respect to the 379 pounds. That was the green vector. So when I go back to this resultant picture, I have to find out the degree between my red vector and this green vector. Or this was an angle of 9 degrees. So I'm going to take this 17.1685 and add 9 to it to get 26 point, and we can round now, we're at the end, 26.2 degrees. That is 26.2 degrees between the resultant vector and the vector that had a force of 379 pounds. So my final answer, here's my magnitude, and here's the requested direction.